Parallelograms. All right, so I want to focus. We're going to focus 3 days on it today, on the parallelogram. Today is all the properties in the algebra. Tomorrow are proofs with parallelograms, and day 3 will be more proofs with parallelograms. Right, so we're going to spend 3 days on this. 3 days, and that's pretty much your quiz. The quiz is going to cover interior, exterior angles of polygons. What we did day 1. All the trapezoid stuff we did, and then all the parallelogram stuff we're doing. That's your quiz on Tuesday. All right, that's your quiz. All right, let's start here. Let's call this parallelogram. And I'll stop right there. That is the last time I write that word completely. Good spelling word, by the way. A week from tomorrow. Week from tomorrow. Spelling bee. Week from tomorrow. That's a good spelling bee word, but last time I want to write that all out. Here's my abbreviation, and you are allowed to use it on any test, quiz, midterm, or Regents exam. Parallel-ogram. There you go. Don't be that embarrassing student. What's an 11ogram again? What's an 11ogram? Don't be that kid. Okay, that's embarrassing. But this is going to be parallelogram ABCD. And we've been talking this unit how to properly label a quadrilateral, clockwise or counterclockwise. So go ahead, label your parallelogram ABCD in any order you'd like, except for diagonally. And now let's talk about properties. Let's talk about the properties of a parallelogram. We already have a lot going on, don't we? With the trapezoid, we already have a lot going on. I'm going to add to your plate right now. Keep them all straight. Keep them all straight. Here's your first property of a parallelogram. It's got the word what in it? Parallel. Oh, parallel. Opposite sides are parallel. Opposite sides are parallel. Both pair of opposite sides. So, hey, arrow, arrow, double arrow there. Opposite sides are parallel. Now, I want you to understand when you would use that. All right, why would I need to know opposite sides are parallel? Please draw in diagonal AC on your diagram right now. Draw in diagonal AC, and I want to show you why knowing the opposite sides are parallel are going to help us. You just drew in diagonal AC. Anybody know what type of angles you just formed? From our parallel line unit. Those are called alternate interior. Also, those are congruent because those are alternate interior with AB and DC. So I'm trying to tell you, that's just the first property. But anytime you were dealing with a parallelogram with at least one diagonal drawn in, you better look for what type of angles? Alternate interior. Be aware of that, please. All right, that's what comes from that property. If you have a diagonal or both of them drawn in, be ready for alternate interior angles. All good. All right, next up. Opposite sides are parallel. Opposite sides are also congruent. So those parallel sides are also congruent. Good so far. Let's talk about opposite angles now. Opposite angles are congruent in a parallelogram. Opposite angles are congruent. So can you do real quick right next to that property, because it's going to lead us into our next one. Draw yourself a little tiny parallelogram right next to that bad boy for me. I want you to understand the next one. Let's put 120 degrees in that corner right there. You don't probably believe it, but you should be able to find the remaining 3 right now. Talk it over in your group. Hurry up. What's the remaining 3? Based on the property I've just given you and the first property. Across from the 120 has to be another 120, right? Because that's the property I've just given you. And if these are parallel, again, similar to the trapezoid, what type of angles are these right here? The 120 and one of the missing ones. Those are same side interior, makes them supplementary. So I should also get 60, 60. This leads me into my next one. Consecutive angles. 2 angles in a row. You finish the statement for me then. Consecutive angles. And again, it's the best word I could use here. Consecutive, which means 2 in a row. 2 adjacent angles. 2 in a row. Consecutive angles are, anybody want to finish it? Consecutive. Not opposite, consecutive. They are always, Connor?
Supplementary.
Supplementary. They add to 180. Consecutive angles are supplementary. And the fifth and final property of a parallelogram, go back up to the diagram and now draw in diagonal BD for me. Draw in diagonal BD. I'll mark the property on the diagram. You tell me what that property is in words. Ready? Using vocabulary terms from this year. What's up, Abby? What am I showing you here?
Diagonals bisect each other.
Darn right they do. So in a parallelogram, the diagonals bisect each other. That's a lot of properties, kids. Good thing we're spending 3 days on them. So there they are, 5 properties of a parallelogram. Questions from any of you guys before we start doing some, that's all we're going to do today is some algebra using these properties. All right, let's do it. Find the value of x, then I want to know what property you used. Okay, find the value of x, tell me what property you used up there. All right, so I have 10 on that partial diagonal and 2x minus 4 on the rest of it. Using our properties of parallelograms here, what do I know about the 10 and the 2x minus 4? Where am I going with that one? What do I know about those two? Henry, what do I know about those two?
The diagonals bisect.
So that means those two are congruent. Yes, those two are congruent. So 10 is equal to 2x minus 4. I know I'm starting you out with the tough one. 2x equals 14. X equals 7. All right, now notice it says theorem used. I'm getting you guys in the habit because guess what we're going to tomorrow? Proofs, and this is going to go in your reasons column if you ever want to use it. What do you know this figure is? So that's how we're going to start it. Parallelogram, and you can use my abbreviation. Just like we did with the isosceles trapezoid proof. You tell me what the figure is, implies. Now tell me what property you used. Henry, going back, you already said it. What property did you use here to set them equal?
The diagonals bisect.
There you go. So parallelogram implies diagonals bisect each other. That's all I need. Even quicker than number 1 is number 2. How about the value of x here? Oh, where am I going there? Jacob? 16, because parallelogram implies what property did you just use there? Opposite sides congruent. Good. And one more here involving segment lengths. What do you know about the 3x minus 2 and the 4x minus 10 on that one? Oh boy, so many kids, so many kids. There we go. Catherine, sorry.
4x minus 10 equals 3x minus 2.
Yes, it does. And we should get x equal to 8. How'd you know that, Catherine? Perfect. All right, there's only so much I can do with segment lengths here, so I really want to turn our attention to the angles now. You do not need to provide me with a theorem for these. You do not need to provide me with a theorem. I'm going to let you go and do this in your groups here. But before you go, can I give you a couple pieces of advice, please? Because you might get stuck. First piece of advice, what did we just talk about at the beginning? That if you had a parallelogram with at least one diagonal drawn in, look for what type of angles?
Alternate.
Okay, so please remember that when you're working with your group, because as I can see from your paper, number 2 and not 2 and 3, but 5 and 6 have at least a diagonal drawn in. So look for alternate interior angles. And my last piece of advice, you don't have to go in numbered order. You don't have to go 1, 2, 3, 4. Find whatever you can find. Even if it's a blank angle I don't need, it may lead you to one of the ones I do need. So don't be ashamed of finding one that's not asked for. Find it, it may lead you to another one. Go ahead, you and your group. 4, 5, 6. I don't need any theorems. I don't need any theorems. Please don't move on to 7. We'll do that one together. Compare with your group. Sounds like people are rolling solo, so compare with your group. Make sure everyone's got, if you don't have it, somebody's right, somebody's wrong, probably right. So compare with each other.
What'd you get for 4?
Yeah, I was.
And 2
Because I was saying, because I was thinking that they're triangles, and so that adds up to that. I got.
What do you get for 4?
I got 3. One of them.
Wait, which one are we doing? What?
Another set. So I got 40. 22.
I got 61, 72,
Yeah.
108.
And then 72, 36.
For number 6, I thought 61, 72, 73, 68.
Because number 3 is 108, right?
Ooh, looks like we got some discussion happening. I like it.
Six.
Discussion.
So 108 is
Oh, yeah.
triangle right there. So we put I. So
I never went to.
Talk to each other. How'd you get that angle if you guys are disagreeing here? And remember, it's okay to find a blank angle if it leads to a numbered angle.
I made this a triangle and then I did. That's what I did. So wouldn't that be? I did this.
Wait, tell us, wait.
August also,
Yeah, 36.
anything, the soil chart, and half of that is.
You think you better?
Did not pass?
I know if I work, I still have 61 pages. Word.
I have to get a 50.
You get 40. Okay. This angle.
And, oh, the
Angle
number
2
two
is 72.
and,
And angle for.
Angle 3 should
Wait, did you have a biology?
It's on a straight line.
It's real biology. Goodbye.
Well, these angles would be congruent.
All right, let's do this.
But it's
Here's-
on a straight.
Here's number 6. Hopefully no issues with 6, right? Anything with 6, 40 and 140. Wow, how about 7? That's a lot to look at. I'll start with angle 1, which is 113. Opposite angles are congruent in a parallelogram. I'll do angle 2 next because angle 2 is an alternate interior angle with 45. Yep, look for alternate interior angles. Angle 3 is alternate interior with 22. Look for alternate interior, and that is it. And then we get the big one here, 8. Lot of discussion on 8. I liked it. The first one I did was angle 2. Do I always need to use parallelogram properties? No. All I did here was vertical angles are congruent. And then I went to angle 3, and I said linear pairs are supplementary, so that's a $1.08. So those first 2 came pretty easy. And then we had a little bit more here, right? I said to myself, all right, well, 1 is alternate interior with that one. And how can I find that angle? 3 angles in a triangle I'll add to.
180.
This is unbelievable. We're using stuff from all different units. It never goes away. That's why I love teaching this course. Angle 1 is 61. Dun, dun, dun. And angle 4, I knew that angle was 40 because it was alternate interior with the other 40. I just found angle 3 was 108. Subtract them all from 180 because they're all in a triangle. We got a big 32 degrees there, kids. How are we looking? All right. I'm trying to drive home the fact it's just not about parallelograms. Look in this problem alone, I used vertical angles are congruent, linear pairs are supplementary, 180 degrees in every triangle, and some parallelogram properties just to get those angles. Questions before we go to the last one? All right, let's do it. Some of you have done it, some of you have not, so I'll give everyone time right now. Please graph parallelogram WXYZ. You'll have to do this tonight. That's why I provided graph paper. And another problem you'll have to graph as well. I do not care if you use the straightest of straight edges here. You are just not going to connect these bad boys and see if you can find the point of intersection. We're going to do a little more mathematically than that because I have no idea right there. I have no idea what that point is. What could be halfway up the y-axis, could be a third, a fourth, 3/4 up. I have no idea, and we're not going to guess. We're going to do this mathematically. But they are diagonals of a parallelogram. So what are they doing to each other? They are bisecting each other based on our properties. All right, so let's keep going with that. I didn't mention it when I showed you this property because I knew this problem was coming up. We're ready. That intersection point is the what of diagonal ZX? It's the midpoint, right? Because both sides are equal. And I'm not even done. Let's go to diagonal XY because that one's getting bisected. It's also the what of XY. So if you want to find the intersection of the diagonals, what do I need to find? The midpoint of one diagonal. You don't need to find the midpoint of both because they're going to be the same. So in a parallelogram, the intersection of the diagonals is the midpoint of each. And no, I will not provide that formula for you. We've already used it this unit. So pick a diagonal, find the midpoint. What did I choose to use there? I used WZ. Nope, I used 5 plus 8. I used WY. If you want to do both, just to ensure you do have the right answer, sure, go ahead. All right, but the midpoint is going to be the same for both diagonals because they bisect each other. And I am getting 0, 1.5, doing the midpoint formula on at least one of them. Okay, add your x's, divide by 2, add your y's, divide by 2. Again, I have in the bottom of your notes where the homework is listed, you do have to use graph paper for 21 and 37. It's on the back table if you need it. So go ahead and get rolling, kids.